Welcome to the Deep Dive. Today we're going to get into a massive conceptual jump.
A huge one.
We're exploring how certain 19th century physics concepts, ideas about a material vacuum or an ether, have suddenly resurfaced.
And they're driving breakthrough 2025 technologies. We're talking free energy, propellantless propulsion.
And even localized temporal displacement. The sources we have suggest science has finally closed a 140-year conceptual gap.
It's a powerful premise. Specific variables that engineers, for decades dismissed as just noise in the math.
Right.
They're now being recognized as the actual keys to what's called over-unity energy extraction.
Okay, so let's start with the mathematical history. Back in 1865, James Clerk Maxwell's original theory. Oh, it was dense, right? 20 scalar equations.
Exactly. And it viewed the vacuum as a dynamic, pressurized fluid, an ether.
Then Oliver Heaviside comes along in 1884 and simplifies it all down to the four-vector equations we all learn today. What was the consequence of that? I mean, what did we actually lose?
We lost the entire concept of a dynamic substrate. The simplification was great for engineering, sure, but it threw out a critical component, the scalar potential.
The scalar potential.
That variable, it represented the physical reality of stress and pressure and even compressibility in the vacuum itself. By getting rid of it, the model was essentially blinded to the vacuum as an active, energetic medium.
And that brings us right back to the 19th century foundation, the idea of a material vacuum.
And Lord Kelvin is the key link here. He tied fluid dynamics directly to electrical theory.
With his Vortex atom theory, the idea that matter isn't fundamental particles, but stable rotating filaments of an incompressible ether.
And what's so fascinating is how close that is to what we're finding now. Kelvin's view means the universe is bathed in a high-pressure fluid.
So gravity isn't a force pulling us down.
It's a universal pressure pushing us in. Mass acts like a localized void, a low-pressure zone, in this space-time fluid. The goal isn't to create energy.
It's to build a sink.
Exactly, a sink that draws that ambient pressure in to do work for you.
This concept of a material vacuum is, well, it's precisely where Nikola Tesla diverged from standard physics. He rejected the transverse waves.
He did. He focused on longitudinal waves, their compressions and rarefactions of the medium itself.
Like sound waves traveling through air.
Precisely. Tesla used these non-Hertzian compressions of the ether, claiming they could achieve lossless transmission and, what's really remarkable, superluminal velocity. He cited speeds of 1.5 times the speed of light.
And now there's a modern justification for that.
There is. We have mathematical derivations showing that electroscalar waves, derived from that scalar potential we threw out, are non-zero in a vacuum. It validates his observations.
Okay, so if Tesla gives us the wave, how do we efficiently create that low-pressure sink in the ether?
This is where Victor Schauber's